Welcome to The Explainer. Today, we're pulling back the curtain on artificial intelligence. We're going to see how it goes from, believe it or not, super simple math, all the way to having an intelligent conversation. You know, we hear about AI, neural networks, ChatGPT, it's everywhere. But have you ever stopped to wonder what's really going on inside? I mean, how does a machine actually think? How does it take what we ask it and turn that into something that makes sense? So in this explainer, that's exactly what we're going to do. We're going to build an AI right from the very beginning. And you might be surprised to hear that it all starts with a super simple building block, an equation you almost definitely learned back in school. All right, let's get into it. The most basic piece of an AI's brain, what you could call its brain cell or a neuron, well, it's not some complicated biological thing. Nope, it's just a simple math equation for a straight line. That's it. This little equation, y equals wx plus b, is really the heart of everything. The w is what's called the weight. You can just think of it as the steepness of the line. And b, that's the bias. It's just where the line starts. Simple as that. And get this. This is the key to everything. The whole giant, complicated process of training an AI, it all boils down to one thing: finding the perfect W and B values, the perfect weights and biases to solve whatever problem you give it. That's the entire game. Okay, so one of these little neurons on its own, it's not going to do much. It's like a single Lego brick. But the real magic happens when you start snapping thousands or even billions of them together. That's when you get a network that can actually learn something incredible. So how does this work in practice? Let's use a really classic example. We're going to teach our new network how to recognize handwritten numbers using this famous collection of images called MINST, which is basically just thousands of digits scribbled by thousands of different people. Okay, so here's how the AI actually learns to see. First, you take that picture of, say, a 9, and you just flatten it out into one long line of data. That data then flows through all those connected neurons. As it goes, some neurons will light up when they see a piece of a pattern they like. Then, the whole network makes a guess. Maybe it looks at the 9 and says, "I think that's a 0. Oops, wrong." And here's where it gets really smart. It sees it made a mistake, figures out how wrong it was, and then sends that error message all the way back through the network, telling every single neuron to tweak its W and B just a tiny bit. Then it tries again, and again, and again, thousands of times, getting a little bit better with every single mistake, until it gets it right almost every time. So this whole process of learning to spot numbers, that's a perfect example of what the earlier AIs were fantastic at. Before the whole ChatGPT wave, these kinds of networks, we call them discriminative AI, were basically masters of two things: sorting stuff and predicting stuff. It really just depends on what kind of answer you're looking for. If you need to put something in a bucket, like is this email spam or not spam, that's called classification. But if you need to predict a number that could be anything on a scale, like what's this house going to sell for, that's regression. Okay, so these models were amazing for sorting and predicting when the data was nice and neat. But they hit a brick wall, a huge one, and that wall was human language. It's messy, it's complex, and it's all about context. Think about it. This was the real puzzle. If you're reading a long chapter in a book, how do you know which words are the most important? The older AI models, they kind of read one word at a time. By the time they got to the end of a sentence, they'd already forgotten what was at the beginning. They just couldn't hold on to the context. And then, in 2017, everything changed. A research paper came out of Google with this incredible title, "Attention is All You Need," and it introduced this game-changing idea called self-attention. The best way to think about self-attention is like giving the AI a magic highlighter. So instead of plodding along word by word, it can look at the entire text all at once. And then it can highlight the words that are the most important for understanding the real meaning. What it's really doing is learning to score the importance of every word in relation to every other word in the text. It's creating this web of connections. And that's how it finally figures out that a word way back in the first sentence is actually super important for understanding a word in the last sentence. It finally gets the big picture. And this mechanism, self-attention, this is the powerhouse. It's the engine inside the architecture that makes things like ChatGPT possible. And that architecture has a name you've probably heard: the transformer. Let's see this in action. It's actually really intuitive. So imagine you ask the AI, "Hey, I need to go shopping for the summer." and it gives you a totally predictable answer, right? Shorts, t-shirts. Makes sense. But now, watch this. Let's add one tiny piece of context. Same prompt, but we add, "but I have a corporate meeting in the evening." That one little phrase, corporate meeting, is about to change the entire game. And boom, look at that. The recommendations totally change. The AI now suggests business casual clothes. Why? Because the attention mechanism highlighted corporate meeting as the most important phrase. It totally overrode the simple summer context and figured out what you really needed. That's the power of attention. So how does the transformer pull this off? Well, it's got this really elegant two-part brain. First, you have the encoder. You can think of that as the reader. It takes your prompt and uses that self-attention trick to really deeply understand what you mean. Then, it hands that understanding over to the decoder, the writer, which takes that deep meaning and starts generating a perfect, context-aware reply, one word at a time. So when you step back and look at it, it's an amazing journey, right? We went from a simple line on a graph to a whole network that learns from mistakes, all the way to a system that actually understands context. It shows you that these incredibly complex AIs, they aren't magic. They're just built on these layers and layers of really clever ideas. So there you have it, a quick tour inside an AI's brain. The big thing to remember is that this isn't some unknowable magic. It's a story of clever building blocks, each one making the next one possible. We started with a simple line, built a network that could learn, and then gave it a way to understand us. It makes you wonder, right? Now that it can understand our context, what's the next great barrier for it to overcome?